So polymers are molecules, very, very high molecular weight. So there's lots and lots of atoms there. And they're made together by a special process called polymerization, and that's why it's called a polymer. Poly comes from the word many, okay, so there's many parts to it. And the building block of that polymer is called a monomer. So whatever that shape of that one unit is, and so you can have lots of different polymers if the monomer looks different. Okay, so if the monomer is one shape and size with a certain number of atoms in it, and then it repeats, then that's a polymer. But you can make a polymer of all kinds of different repeating blocks. So each block is going to have its own shape, made up itself of atoms put together. Okay, so the building blocks for polymers are called monomers. Okay, so I think of a polymer as being a plastic or something like that, but DNA is a polymer because DNA is made up in these repeating units. Remember adenine and guanine, etc. You could also have proteins. Proteins is this way, and then yes, rubbers and plastics. These are polymers also. Okay, so plastics are materials that can form various shape, and usually with heat and pressure. Okay, so here's some common polymers. So polystyrene, that's a paper like a styrofoam cup. Polypropylene, okay, so the big plastic, that's heavy plastic. Polyurethane, which you seal wood floors with polyurethane. Nylon, so there's rope and clothes and all kinds of stuff, parachutes. A lot of these are made out of polymers. In fact, this was the 20th century's big deal, was making these synthetic fabrics. And synthetic meaning you made it in a laboratory. So there's a couple ways of making polymers. So the first one we'll look at is addition polymers. And so by addition polymers, let's look at this first one. So let's take ethylene. And ethylene has a double bond. So it's two carbons, double bond joined to hydrogens. So that double bond makes it a very three-dimensional shape. Okay, so because it's a three-dimensional shape, it's not flat. That is not flat. That is the hydrogens are kind of tilted to the back, so it would almost look like a pup tent, where you have a top carbon ridge and then the hydrogens go to the ground. That idea. Okay, so if you can convert those pi bonds, which makes that double bond, into single bonds, sigma bonds, normal single bonds, then you can end up with a chain. Each of those ethylenes can be joined to the previous bunch that's already linked to a chain, and you can have polyethylene, and that polyethylene chain can be as long as you would want it to be. You could make it into ribbons or into strings that then could join together. So you could have a polyethylene, sandwich bag. That's what they're made out of. It's basically rope, tiny sticky rope. So this is addition. So when you're making single bonds out of double bonds, that's called addition polymerization. The second one is called condensation. And when something condenses, essentially what you're doing is you're dehydrating it. You're taking out of water. So let's, along the bottom, you've got the end of one unit that has a hydrogen stuck to the end. That's a nitrogen double hydrogen amine group. And then you have a hydroxide at the other, the OH group. Well, HHO is H2O, that's water. So if you can remove that, then what happens is the nitrogen can join straight to the carbon. It's basically a lock and key mechanism where the water is removed, and by removing it, it joins the two together. And so if you were to have a unit that ends with an NH2, and then on the other side of that same unit, it would end with an OH, then you simply could put them in order, and make a long condensation one. So this is made by two subunits, billion subunits, reacting where water is pulled out. and these are called copolymers. Okay, so that brings us to an example. So this is nylon, and a nylon, if you were to so on this side of the nylon, you've got the H. Okay, on the carbon, that's the H, or I'm sorry, OH. This is the OH group, and then over here is your H on the nitrogen group over here. So you'll get an H2O, and that's water. Water pulls out, and then this whole monomer. Now look how complicated that monomer is. It would then join and link into a big chain. Okay, so when you have chains put together, these orderly regions where they're kind of stripped together, it leads a structure to the polymer. So for instance, if you were to have just these little rubber bands, it might be too flexible for your needs. It's not stiff enough to make a milk jug out of. But these ordered regions allow it to have a little bit of structure. And if you have a material that's too rubbery and stretchy, you might want to rigify it, if that's a word. You would do it by sticking them together kind of in a 3D structure. Okay. So the first thing, you could stretch them out. If you stretch them out, then you make chains out of them, and then those chains could kind of link together. And as you stretch them, okay, you change the crystallinity of it. It changes all of the properties, the melting point, the yield stress, stretching a paper bag or a plastic sandwich bag. How far does it stretch before it actually breaks? That idea. Okay, so for instance, if you can stretch them out, you might make them more rigid. If they are all branchy and rubbery, you might make them very flexible, and you would want flexible or you would want rigid. It depends on what you're looking for. So if you're making plastics or you're making polyethylene, polypropylenes, even PVC pipe, you would want that you don't want that flexible, you want that stiff. So one way to stiffen it, if you want to stiffen it, is you are going to bond them together. Now sometimes this happens automatically. This is, by the way, how like you can see an egg white transparently when it's raw, but when it's cooked, it's all white. A lot of that has to do with these linking, where the proteins are actually being linked together and the properties change. Okay, that's called crosslinking. So it happens normally, and then you can make it happen. Okay, so if you were to add, for instance, I think this is sulfur to rubber, it's called vulcanization, and this was famous in the 20s because you were able to have rubber tires turn into what we now know as tire material, which is really stiff and rugged, goes over a rock without bouncing on the rock. Okay, so it made car tires a lot better, and it made Mr. Goodyear rich. So this is vulcanization is what it's called. So the sulfur atoms are making it less susceptible to degrade and more durable.